Welcome to lesson 11.2. Here is the vocabulary builder from our chapter. Go ahead and check over your answers. If you need to, pause the video so you can have plenty of time to read all of them. If you went ahead and did the spiral review from lesson 11.1, here are the answers for that. And now let's take a look at today's lesson. Our learning goal today is to be able to classify triangles. So let's unlock the problem together. If you look closely at Epcot Center's Spaceship Earth building in Orlando, Florida, you may see a pattern of triangles. The triangle outlined in the pattern at the right has 3 congruent sides and 3 acute angles. What type of triangle is outlined? So let's go ahead and complete each of these sentences. An equilateral triangle has 3 congruent sides, and we can see that here. They're all the same size, they're all the same angle. And a right triangle has 190 degree or right angle, and that's shown right here. The little square in the corner, remember, means that this angle is a 90-degree angle. So this one is a right angle. An isosceles triangle has 2 congruent sides. Here you see this side and this side are the same, making them congruent. So this is an isosceles. An acute triangle has 3 acute angles. Acute means it is going to be less than 90 degrees. So 75, 75, and 30, all of those are acute. A scalene triangle has 0 or no congruent sides, and here we see each of the sides is different. And here we have one angle that is greater than 90 degrees, so that makes this an obtuse triangle. So if we go back and look up at the pattern in the Epcot Center, the triangle outlined in the pattern, that's going to be those right here. Can be classified by the length of its sides as an equilateral triangle, and classified by its angles, it can be classified as acute triangle, an acute triangle. So let's take a look at the math talk. Is an equilateral triangle also a regular polygon? Well, remember, if something is regular, it means that all of the sides and angles are the same. So would that be true of an equilateral triangle? Are all of the sides and angles the same? Yes. So that means that an equilateral triangle is a regular polygon. Let's try this activity. Classify triangle ABC by the lengths of its sides and by the measures of its angles. Go ahead and pause the video while you fill out the purple box. If you couldn't remember, hopefully you looked back on the previous page. What type of triangle has 3 sides of different lengths? That would be the scalene triangle. And what is an angle that is greater than 90 degrees but less than 180 degrees? That's obtuse. So as we take a look at this particular triangle here, measure the sides of the triangle using a centimeter ruler, label each with its length, classify the triangle by the lengths of its sides. That's pretty hard for me to do with a computer to show you, but hopefully if you have a ruler at home, you could come up with 4 centimeters here, 3 centimeters here, and 6 centimeters here. This angle would be 25 degrees. This one would be 120 degrees, and this one would be 35 degrees. And I'm guessing that probably you don't have rulers or protractors at home, so you'll just have to take my word for that. Hopefully next year in 6th grade you can spend a little more time using those tools to be more familiar with them. So the triangle ABC is scalene, obtuse. So now let's try this. It's going to ask us to draw the type of triangle described by the lengths of its sides and by the measures of its angles. So if I want a scalene triangle, that means that all 3 sides are the same length. And if it is acute, it means that they are all less than 90 degrees. So I'm going to see if I can do it this way, if it will let me duplicate this. Maybe. And turn it. And if I can get those all matched up, I will know that they are a little bit of a trick here, that they are all the same length. That's pretty close. And then if we want an isosceles triangle, oh, I'm sorry, scalene, I need to go back. I have a mistake here. This would not be scalene because the 3 sides are all the same. That would be an equilateral. So let's get rid of some of these sides. Oh. All right, let's try this one more time. Scalene, 3 sides of different lengths. So let's go ahead and make this one and this one. And ooh, I'm not sure I even like this. Let's try this. Oh, and hopefully you have a straight edge that you can use. Computer does not. Oh, hey, I've got an idea. Let's try this. Let's try line segments. That would be a better choice. There we go. Okay. Let's make that one. Oh, gonna be a day. Gonna be a day here. Let's see. All right, there we go. So this angle right here would be the one that is greater than 90 degrees. And these 2 sides, I was trying to get them to be the same size. Pretty tough to do if we don't have the rulers and protractors. Mostly it's going to be important for you scholars to be able to have the vocabulary so that you can identify them. So let's take a look at the math talk. Reason abstractly, can you draw a triangle that is right equilateral? Well, let's think about that. If it has a right angle in it, it means that the other 2 angles would be less than 90 degrees, right? So to be equilateral, all of the angles have to be the same. So that would have to be a no. An equilateral triangle always has 3 acute angles and the sides are always the same length. All right, so now it is your turn. Go ahead and classify each of these triangles. They will get 2 classifications. One will talk about the lines, the other will talk about the angles. Go ahead and work that through and then meet me back to check the answers. So let's take a look, scholars. On this first triangle here, we see that we have 3 different sizes of the sides. That would make it scalene. And it has and it has 3 angles, each of them less than 90 degrees, so that would make it acute. So number 1 should be scalene, acute. Number 2, if we take a look at the hash marks on the sides here, we can see that each of the sides is the same length and each of the angles is the same angle, so that would make this an equilateral, and because it's equilateral and each of these are less than 90 degrees, it's acute. And finally, on number 3, isosceles means that it has 2 sides that are the same. Here we have 2 sides that are the same. These 2 angles are the same, but this one is not. It's less than that. They're all less than 90 degrees, so this would be an isosceles, and it is acute. So let's draw some conclusions. Can you tell that a triangle is obtuse, right, or acute without measuring the angles? Yes, you can. If you think about your benchmark being that 90-degree angle, which is going to look like the corner of a square box, then you'll be able to compare, is it less than that or is it more than that? All right, so if you would, go ahead and jump into today's assignment, 11.2. Make sure you do the spiral review so we can go over that for our bell work tomorrow. Have a great day.